Shashank, how you doing?
Good.
Yeah.
Yeah. It's been a little bit of a slow news week. No crazy AI developments, a lot of drama, but maybe we can try to focus on what little news came out this week.
Yes, let's talk about the S1 paper.
Hmm.
Shashank, have you heard about this S1 paper?
Not until you mentioned it earlier today. It seems pretty cool. It's along the lines of the DeepSeek V3 and R1 models where they're trying to efficiently train these LLMs to get reasoning capabilities.
Yeah, the S1 model seems super cool. So it's a thing that Stanford just came out with, and it's a technique to make any uh model, like any open source model, or actually it doesn't have to be open source, it can be any model, and it can turn it into a reasoning model. So um just a quick definition before we kind of get started, right? When we're talking about reasoning models in LLM world and the large language models, there's two general types of models that we see. One would be, I guess you'd call it like a single shot model.
Mhm.
Is that what you'd call it, right? And then the other one would be like a reasoning model. So I kind of think of it as like the difference between thinking fast and thinking slow, where one of these models will be kind of like ChatGPT, where you ask it a question and it gives you an answer really quickly, right? But then the reasoning models are one where you're going to ask a question and then it's going to go and think about it for a while. So it might take 5 seconds, 10 seconds, it might take an hour, and it might just really think about the solution until it spits out a response. So that's the reasoning model. So um, a small team at Stanford, they came out with a new paper that is able to make the any model. You could use this technique and make it into a reasoning model. So what they did is they took the Quen 32B model. So Quen is the model made by Alibaba, and it's their 32 billion parameter model. So the 32 billion parameter model would be roughly like 32 gigabytes. Would that be?
A little more, maybe like 40 something.
Okay.
Yeah.
Yeah. And then they claimed that it was, when I say they, I mean the Stanford research team claimed that their model was able to, uh, their technique was able to make the Quen 32B model smarter than O1 in a particular domain. So O1 seems to be the better model, but this, what's really special is they did it for $6. This is what they claimed, right? So they were able to take this open source model made by Alibaba, and then for $6, they were able to make something that matches OpenAI in a particular use case. So that is really kind of like crazy, right? The fact that you have all these scientists, you have all these researchers that are working at the Anthropics, the OpenAIs of the world, who are making these reasoning models and DeepSeek as well, right? And then now you just take any model and turn it into a reasoning model and compete with DeepSeek. You could compete with O1. You could compete with, I think even Google has a reasoning model too. They have
Mhm.
like their Gemini Flash model, right?
Yeah. They have, well, the Flash model is another model like ChatGPT. It's a one-shot model, but they have reasoning capability on top of that, which I think they call deep research.
Oh, okay. That one.
But it
Yeah.
might also have some chain of thought built into that model itself.
Yeah. So it's pretty crazy that you can go and then for allegedly $6 and looking through their paper. So I read their paper and it makes sense. So they said that what they did is I'll kind of get into the technique that they used. So they had a data set, and the data set has 1,000 questions. Now, these types of questions are basically reasoning examples. So it would be something along the lines of, like, I don't know, like how many, I don't know, well, now I can't think of an example of reasoning. Would it be like how many sides are, or like how many windows are in New York City? That'd be a reasoning model,
Yeah.
like thing. So you can say like, oh, how many windows are in New York City? It's like, well, nobody really knows the answer, right? So you'd be like, well, how many people live in New York City, right? So it's like one way you could think about it is like, okay, there's roughly I think 7 or so million people that live in New York City. Maybe round it to 10 to make the math easy, and then you say, okay, there's maybe 2 windows per person. Maybe that's one way you could do it, and then you can say, all right, well, if there is 10 million people in New York City and there's 2 windows per person, because I think, or actually think about like this apartment right here. There are one, two, I think 3 windows in this apartment. There's you living in here, but I think on average you could say maybe 2 windows per person, because some houses have more, some houses have less. So you could say, all right, 20 million windows in New York City. That's not the best. And then you can say, oh, well, do you include car windows, or is this only home windows? Maybe it's only home windows. There's skyscrapers, there's office buildings. So you could do plus or minus, but it's probably somewhere on the order of magnitude of, maybe 10 million or so, 10 to 20 million windows in New York City. And that's my reasoning step, just doing that. And I don't know, did you Google how many windows in New York City?
I didn't Google, but I asked a couple different models: Perplexity, ChatGPT's O1 model, Gemini's 2.0 Pro model. Perplexity gave me 12.86 million.
Okay.
Based on similar reasoning, 2.5 people per household, 2 windows per apartment. Google gave me a higher number, anywhere between 29 million or possibly higher, with like 50 to 100 million, which I believe. ChatGPT gave me about 100 million or so. I feel like the Gemini answer was the most thought out and comprehensive.
So how did the Gemini do the reasoning for that?
Yeah. Defining it broke down the question into as many subcomponents as possible. It's like, let's define what is NYC and what is a window. Are we talking about just Manhattan, all the 5 boroughs, the NYC metro area? And window, is it just every single pane of glass, or is it like distinct window units? So it was very detailed in his thinking, and then talked about residential buildings, high rise, mid rise, single family, commercial buildings, other buildings, schools, hospitals. And then it started making like rough estimates: Manhattan, Brooklyn, Queens, Bronx. Then it took like an underestimation and overestimation numbers, and then it put all that together into a conclusion.
Okay, so that sounds even better reasoning than what I did. I just said 2 per person.
I mean, yours is pretty good as a spontaneous reasoning step. Imagine if we gave you more inference time compute, locked you in a room, and said, sit in there for like an hour and then come up with a better answer. I think you might reach a similar conclusion.
Yeah, I think so. And actually, I'm really happy that you explained what Gemini did.
Yeah.
Because it turns out that the Stanford team that made this data set, they happened to do what's known as distillation from the Gemini thinking experimental model. So it's one of Google's models that has some reasoning steps. So basically, they took a data set of 1,000 of these types of questions, where it'd be something like, how many windows are in New York City?
But specific to math.
Yes, it was math and science.
Okay.
And they tried to get a bunch of questions around math. So I don't exactly know all the different subdomains of math, but you might have something like
geometry, trigonometry.
Yeah, calculus. I don't know.
Linear algebra.
Exactly.
A bunch of different stuff.
All that stuff, right? So they took all of that together and they said, hey, we want a good breadth of questions and also just super high quality data. So I think a lot of this was handpicked to be really high quality data. And then they used that data set and did supervised fine tuning on the base model. So supervised fine tuning is basically just a step that you run on a base model. So you run it on your Llama, you run it on your Quen, you run it on your, I think you could even do some fine tuning on OpenAI's models. They have some APIs that allow you to do that. And you basically just show it more examples. And then they used 16 H100 GPUs for 26 minutes. And then they were able to train the Quen 32B model to be equivalent at math to O1, which is quite impressive if you ask me, that you can just turn any model into a reasoning model. Now, I somewhat question the $6 because I don't know where you can get because I don't know 16 H100s. I think it's typically around like $1, $1 to $2 per hour that you would rent those for. So I think that if you did 16, assuming it was $1 per hour, that would be about $8.
Yeah, so Perplexity cited some other estimations of how much it costs, which is floating around, and they say around $50, which is still in the same ballpark.
Yeah.
Not a whole lot of money, very efficient, very cheap, but we have to take some things into account. So they didn't fine tune this model to be capable in all domains. They picked a very narrow domain of math and apparently science too. They didn't have to train this on any massive model. It was a very tiny model. If we're comparing it to DeepSeek, which was some numbers floating around,
I think it was like 600 something billion parameters.
Right. And it cost around $5 to $6 million to train the V3 model at least. This is what, 32 billion parameter? So it is significantly less, an order of magnitude less than DeepSeek. And it also focused only a single domain. So I can believe that it cost very little to train this model.
Right, but I think that with DeepSeek, so by the way, if you guys haven't seen our deep dive on DeepSeek, check out the previous episode. We talked for about an hour all about DeepSeek, but really quickly, for those who have been living under a rock, DeepSeek is a model that was made by this Chinese hedge fund. Do you remember the name?
High Flyer.
High Flyer, yeah. And it is a reasoning model that competes with O1, where that is a lot that was made for reportedly about $6 million.
Yeah, and I think we can take some parallels from how they worked on DeepSeek and this Stanford S1 model. So from my understanding, the essence of what they did is called distillation. They distill the capabilities of a much bigger, larger model, like Gemini in this case, to get a high quality training data set of about 1,000 examples, and then use that to train the smaller model and give it a capability that is significantly more than it could have achieved by its own. So DeepSeek did that. We assume by using OpenAI's O1 models or some other more capable model, maybe Claude, and the Stanford S1 model is doing that with Gemini. So it's kind of like a hack to use this better, bigger model to give you curated training data to train a smaller model and give it more capability than it could have achieved by its own.
Yes. And actually, I think that's a really good point to kind of go on top of. When we say it's $6 or $10 or $50, it only is sort of, right? Because this is just the final step in making the model, right? Because you had to start with another base model. And now Alibaba might have spent $100 million or something making their Quen model. We don't know exactly how much they spent, right? But Alibaba is a huge company, likely has huge amount of resources and tons of GPUs. So they spent a ton of time, money, and effort training this model. So in reality, it's like, I don't know, $100 million plus 6, right? Which is, you have to start with that $100 million model. Now, the model exists, so likely we can do this technique with other models, but it's not a $6 reasoning model. You had to start with something else, which, I mean, I don't know. I feel like we need to make that distinction because it's not like you can just go with $6 of compute and then make your own reasoning model. Plus,
not from scratch.
Right, not from scratch. And also, you have a rental, like you have to rent these H100 NVIDIA GPUs. So if you bought these H100, like the H100 is
60 grand or something.
Yeah, 50K, 60K, right? So um, they actually used, I guess, assuming it's 50K times 16. What is that? I can't do the math.
Again, this is not to mention all the research that they would have needed to do to end up on this approach and decide, okay, this is going to be our final run. We're going to train it. They would have done a lot of research, experimented with a lot of different approaches, a lot of which might have failed. Like, you don't get success without immense failure to experiment, push the domain, and figure out what works, what doesn't work.
Yeah,
So this is one successful approach that they tried, which cost this amount. It doesn't include all the research, all the GPUs that they already bought and own in order to run these models or run these training runs. So there's a lot that goes into this.
exactly. Yeah, and I was just doing the math. If an H100 costs 50K, then 50K times 16, that's 800,000. That's $800,000 worth of GPU that you rent for 20 minutes, right? So it's like, all right, fine. You rented that for 20 minutes and then you were able to make this, but it's like really almost $1 million worth of GPUs and data centers. So I don't know. To say it's only $6, it's like kinda.
Kind of. Well, I mean, one could argue that the availability of on-demand GPU resources is just so widespread. Every single cloud provider has on-demand pricing, and a lot of open source models have come out. So you don't need to train or build a foundation model from scratch. You have tons of very permissive licenses from these companies that allow you to just take it and start a company if you want to. So we're living in a very tricky new world. I think each country also has their own restrictions on who can use what model and what kind of restrictions you can place on open source, and at what scale they'll like kind of jump in and have a say in your company. Beyond a certain size, I think the US requires companies to report, okay, what kind of model did you train? What insights does it have? What training data did you use? So if you're a hobbyist, a researcher doing it on a small scale, I think you'll be fine. But this is a complicated, multifaceted industry.
Yeah, it is pretty interesting about how there's all these rules around what we're building.
Yeah.
But anyways, getting back to the S1 paper, there's one other thing that they did which was quite interesting.
Mhm.
So they used a technique called budget forcing. I never actually heard that term before, and they may have made it up. I'm not sure. But the way I understand budget forcing is basically force my budget because I don't want to spend too much. So basically, I'm a broke college student. Make it so that my budget stays under $10. So
Or I'm an investment banker and make sure that my minimum budget stays at 5 minutes of reasoning.
yeah, also that's true. Yeah. So it could be either money or it could be time. Yeah, that's a good way to.
Well, I just more meant that you can set a maximum and a minimum budget too.
Oh yeah, good point. Good point. So what this is they said, hey, we want to limit the total number of tokens that we use, or have like a minimum number of tokens that we use. So let's say you have a question and you want the model to think for a long time. So let's say you're okay waiting a day or a year for the model to think. So let's say you say, hey, look, I really, really, really want to cure cancer. This is super important to me. I will wait.
You got 5 minutes.
Yeah, exactly. Like,
Or 3 years.
right. It's like you can.
Yeah.
And it's not clear if you thought for 3 years if it would actually get any better, but in theory, you might be able to reason for 3 years. I don't know. You could keep Googling around, reading research papers, thinking, combining the research together, keep reasoning, and then you could ultimately solve cancer in theory, right? But then the other thing could be true. You could say, how many windows are in New York City? And you can say, well, it doesn't really matter. I don't care. Like, just give me something that's good enough, right? So you've got 10 seconds
Mm-hmm.
and you could think that way. So the technique that they use, budget forcing, would say if you are um, above our token limit, to say, hey, you've already thought for the 10 seconds at New York City, we're going to give you a command to stop, to say, hey, just stop thinking. And then the uh, the thing that they would do if they want you to think more, let's say they really want you to cure cancer, they want you to think for 3 years, then they just would append wait to the bottom. So they just say like, hey, model, like, wait, hold on. And then that would uh, prompt it to continue to think more. And then I guess they could just continue to give wait and then say wait. And then it would just continue to think more and more to help get more accurate results. So I think this is like a pretty cool technique to use it to get it to think more or less. Because a little bit of story time. I tried to build an agent. So not exactly a reasoning model, but I wanted to build an AI agent to be able to do stock research. So I said, hey, can you think about can you find the intrinsic value of Tesla? And I used my OpenAI credits to try and come up with the intrinsic value of Tesla. So I gave it access to, I think it was like Google search or DuckDuckGo. And I said, all right, you have the ability to call the internet. And I think I gave it a calculator so it could do whatever math it wanted. And then I said, just keep on asking questions to figure out what the true intrinsic value was. And then it started doing some research, and it started going and looking at the value. It started doing some cursory level research that you might do. It said like, oh, what's the intrinsic value of Tesla? And then I think it found some articles about Tesla. And then it started going off and looking up things about Elon Musk. And then it went down this whole rabbit hole looking at Elon Musk. And then it started looking at electric cars and the history of electric cars and just kept that going forever. And one, that got very expensive for me very fast.
I bet.
Yeah. And then two, it just never ended. So I had to stop the program. I was like, all right, I'm just going to not work on this for a little bit because
What was the agentic framework that you were using? Were you just stringing together LLM calls by yourself or using something like LangChain?
I was using I think there was a framework that I was using, but I don't remember exactly what it was. I actually may have just been stringing together LLM calls. I don't remember. I don't remember the answer for that. It was one of it might have been AutoGen.
Okay.
I think I was using that. Or I know there's some other models. If I remember, I'll mention it, but I can't remember. But it's not exactly the point that I was trying to make. So the main point is, if I would have said like, hey, you've done enough reasoning, just stop it, then I could have forced my budget and made it so I don't spend too much. Now, luckily, I had a $10 cap in OpenAI, so I didn't go beyond that, but I think it got pretty close, like really quickly, because it just kept on searching. So yeah, I just didn't want to do that again. And also it didn't give me a solid answer on what the intrinsic value was, because I never like was able to force it to stop. So I think that if I would have had something like this to force it to stop, that would have been kind of the way to go. So yeah, I think that it's just really interesting that people are working on these techniques to make any model a reasoning model. And then I started to think, okay, like what? And then I started getting a little philosophical thinking about this, and I started thinking, like, okay, what are the limits of reasoning, right? So, like, in this model, in the S1 paper, they said, hey, we are able to do this for math, right? Because you're able to get really solid reasoning data for math, and also you can prove that an answer is correct, right? So we have mathematical proofs. We know that you can prove something.
Mhm.
But then I was thinking, like, well, what things is it not possible to come up with reasoning data for? So then I started thinking, well, maybe something like translation is something that it's not possible to have um, a complete reasoning data. Like you can have some reasoning data for it, but I think that you could never get superhuman performance. So I was sort of thinking like, okay, how could you use this technique to beat humans at a particular type of reasoning? Now, math, it makes sense to me that you could say, hey, I can make a bunch of synthetic data for math and I can use reinforcement learning and I can just show the model a bunch of different examples. And then with that, it can get really, really good at reasoning. And then in theory, it can be smarter than humans at math. And then maybe these models will be the thing that we need to solve unsolved problems, right? But then I was contrasting that with something like translation, where if I say with translation, let's say I was going to translate, because Shashank, you speak a couple different languages, right? Like you speak English and Hindi, right?
I speak English, Hindi, Kannada, which is my local language in India, a little bit of Spanish, French, Arabic, Duolingo level Chinese, lots of random little things. There are some similarities in a lot of languages, and I think Google Translate does a pretty good job at translating, and I think that's the whole, you know, the as much as the world has changed since ChatGPT, the original intent of attention is all you need was machine translation for translating for Google Translate. That's the whole reason why they built the transformer so that it could understand the context of a word beyond just, that specific word, like night. Is it like day and night, or like a medieval warrior from the church? So I think to maintain context and remember what this word means within the span of a longer sentence, they use the transformer, and I think it does a really good job.
Yeah, so I think it does do a good job. And that is really impressive. I didn't know you spoke like 12 languages.
Not very well. Not
Yeah,
very well.
yeah, I only speak English and not even that well.
I think you do a good job.
All right, well, I appreciate that. It's okay, but I only speak that, and I am
Japanese too.
so all right. Before we get back to the part. I am going to be enrolling in a Japanese language school, and I went through a uh, kind of like an intro test, and my Japanese is really quite bad.
Oh,
So they have, I think it's like 5 or 6 different levels. So they broke it up into like beginner, upper beginner, lower intermediate, intermediate, upper intermediate, and then advanced and upper advanced. I think there's like 6 or 7 levels. They put me one from the bottom, so I'm upper beginner. So I'm really quite bad.
that's not bad.
I mean, I appreciate that.
That's more than I can say. Yeah.
Yeah, so I'm an upper beginner. So I'm gonna enroll in Japanese language school for a month, maybe 2. In a week, I'm gonna be flying to Tokyo and doing that for a while. So we'll be doing a few different remote podcasts going forward. But yeah, that is happening.
So okay, so stepping back a little bit, I think you presented a lot of speculative philosophical ideas, and I think about translation. I think machines can do a much better job at translation because we sort of like keep comparing these models to AGI or ASI, which is like general intelligence or artificial super intelligence, but I don't think that's quite the right word. There was someone else on one of these online platforms, maybe a podcast, that mentioned it's not super intelligence, but it's like super knowledge. It just knows everything about anything that's on the internet. It may not be able to reason as well as we do about any specific topic, but it just knows literally everything online, which is inhuman. It's more than any single person can realistically keep in their mind. And because of that, I think they have an advantage where they can pull context out of esoteric domains and use that to give you a better translation from any one language to another.
Mm, I so I think that I agree that the language models will be um, better than any one human about
Specifically translation.
translation. Yes.
And all humans actually, because of how much context they have and how much they know about every single word that is out there in literally every single language, probably that it's taught to understand.
So I think that I would partially agree, but I have like a bit of a nuanced point that I want to make about like translation,
Mm-hmm.
and just kind of like reasoning in general. So, um, I think that almost by definition, you can't have, um, you can't beat the best humans at translation because it's not really possible to be um I would argue it's not possible to beat humans at translation because translation is almost like a human thing where I'm trying to articulate this well, but it's like with math we can, or like with chess, right? So chess is really easy because you can play the game of chess and you can always win, right? So if you played 100 games and the machine won 100, all 100, you can say, all right, the machine is clearly better than our best grandmasters, right? But um, I don't think, and maybe we could run these, maybe someone could run the experiments, but my intuition says that if you had somebody who was, let's say, native level in two different languages. So for you, let's say you were native level and you were translating between English and Hindi, right? I think you would be able to do a better job, uh, or maybe like about the same job as the AI model. So
Mm-hmm.
I think that the AI model would never be able to surpass you. I think would only ever be able to equal your translation ability. And I think that my intuition is that if you did 100, let's say you did 100 different papers, right, that you were translating, I think that people who were guessing, who were maybe native speakers in both, they would roughly pick either your or the LLM's translation roughly 50% of the time. I think that they would only be able to guess, but they would never definitively say that the LLM did it better. And I think the reason is because language is kind of like a human thing
Mm-hmm.
where uh, you're using language to communicate with other humans, and it almost doesn't make sense to be more better at like, I mean, you can be better at translating, but I think that the limit is humans because like we're essentially dumbing it down to humans. If that makes sense. I don't know if I'm explaining that really well.
I don't know if I agree with you. So if you take any other human invention that could be formalized into a set of rules and that could be reasoned mathematically, let's say like stock markets, I think machines are way better at understanding, predicting stock prices than humans. And I think the DeepSeek parent company is a prime example. They're a hedge fund, and they use, I'm assuming, a lot of computation models, which is why they built DeepSeek in the first place. Now, I did cross-reference and check if LLMs are actually better than humans, and the current state of the art is no. Specifically because there's a lot of cultural nuance to different languages, and especially regional dialects, local variants, slangs, things like that, that is hard to comprehensively document in a training data for a model. And I think it's just a limitation of what kind of training data we have. If we collect every single phrase that is uttered in every single local dialect of every language, then I think LLMs can be much better. I I don't think it matters whether or not humans invented language. I think it only matters whether or not you can feed in training data, which is just a lot of examples of text into a model, And then these models have this remarkable ability to condense words from different languages into some kind of a meta representation in n-dimensional vector space, and then go from one language to another um, through this embedding vector, which represents the true meaning of words in, numbers.
Yeah, so I get what you're saying, but I think that I guess the point I'm trying to make is uh, if you had something like chess, to go back to that example, right? You can have the bot play itself,
Yeah.
and you can have the bot play against superhuman levels, right? But you can, but when it comes to translation, you can only ever throw more example translations, right? Like you can never have, you can only ever train off of human data, right? Because
That humans are creating in real time, maybe.
right. So you can only ever do it off of human data. So
There'll be some Gen Z kid which comes up with a slang that an LLM just would not understand, because it's happening as we speak right now.
right, because like language is kind of like a fluid thing, and it almost by definition, I think that you can't have language. It wouldn't make sense almost by definition to have language be like superhuman, right? Like because you're never going to. I feel like I'm not like exactly getting my point across.
I see what you're saying. I think I intuitively kind of understand where you're headed. And maybe to articulate a specific example is, because we are creating slangs in real time, we cannot feed in all of the new words that exist into an LLM before they exist, because we're doing it in real time. Do you have any other examples of different domains?
Of different domains. Yeah, so I think also like history. Like history is something that already happened. And the reasoning doesn't exactly make sense in history, because it's just like, okay, these are the events that happened. And then maybe you could potentially feed in all the world's history. And maybe the LLM could have new interpretations. But I think that it would never be something that would be deemed superhuman, almost by definition, because
You mean the interpretation of historical events?
the interpretation of historical events could never like far surpass human level intelligence, because I think that it may be impossible to get like a feedback loop where it could continue to iterate and then achieve like superhuman level intelligence. So I think that like I think that the meta point that I'm trying to make is there are certain types of things that I think that the computer can far exceed humans, right? Like I think math you can objectively verify, and then the computer could get really, really good, and then it could write a mathematical proof, and then it could go and then solve that proof, and then you could go and then say like, hey, math is kind of like a game. We are making a proof, solving the proof. Like I've proved that this mathematical theorem is true, and then it could build off that and then continue to iterate, right? But for something like language, you can never get that kind of feedback loop where you're completely improving and then like saying you've got like the only thing you could ever match is like human level performance. So I think that like with science, you could run an experiment, say like, hey, look, I ran this experiment, I invented this drug, now I'm going to run some sort of simulation and say, like I can have like superhuman performance, right? But I think when it comes to the almost like the humanities, like philosophy, the things that are like purely human, I'm not convinced that you could ever get like superhuman reasoning and then maybe human level intelligence, almost because by definition, humans are the one consuming it and the ones creating it. Not just that machines can't be better at human created things, but like I think language is like the way humans talk to each other, right? So it'd be different if there was a way that humans could talk to each other that would be better, right? But let's say machines are really good at talking in ones and zeros to each other, right? So maybe they would prefer to have some sort of higher bandwidth language, but us humans would be too stupid to understand it.
Mm-hmm.
So it like wouldn't make sense for us to communicate in ones and zeros. So like kind of like we're the bottleneck and we're the limit. So you can never get to this superhuman intelligence. So I think that like another meta point I'm trying to make is there's only certain things that we'll be able to achieve like artificial superintelligence for. And when I say artificial superintelligence, I mean like far surpassing humans. And I think it could probably only be in like the maths and sciences. And I don't think it could ever be in something like translation. And I think it would only ever match human intelligence. And like the best translators would, like, I think it'll probably reach the asymptote where like the AI will match the human level translators, but it will never beat or maybe it'll just match, but like it'll never like beat by like a large margin. It'll just be roughly equal to.
I see what you're saying. Yeah. I think this kind of relates to some of the discussions we've had in the past about how do we make the models better at scale. And a lot of the examples talk about self-play. So chess, as you were talking about, just have the model play itself like a bazillion times, and eventually it just sees so many possible combinations of the board that it sees way more than any human can. I guess similarly with math, with some scientific fields, biology, with AlphaFold, it can look and extrapolate combinations of protein sequences and molecular combinations that it's infeasible for a human being to do. So the fact that it can work in these domains and just collect training data on its own by poking and prodding at real world data or like some kind of a simulated environment, like self-driving, for example, where it's just driving in this 3D model world and collecting more data. I agree. I think in those domains, it can reach superhuman intelligence because it's just collecting more and more data. And at some point, maybe like it will start seeing diminishing returns, but not no returns. It'll keep improving at some point. But yeah, I think with translation, I still have hesitation because I think it can still do a better job than most people. But you're right. I think by definition, we decide what it means for words to represent some concept. So we decide what the translation is, and the best the machines can do is match that translation.
Yes, exactly. I think that's better than what I was trying to say.
I think it was solid. I think it was solid.
So, yeah, this is the types of things that I was thinking about. And then the other thing I was thinking about is how do we approach the problem for superhuman intelligence when there is a delay in getting the reasoning response? So with math, you can iterate really quickly because you can write a mathematical concept and then you could write a proof and then you could prove it and then you could iterate from there. So I think that we could see some sort of type of thing where you figure out some sort of math model and then the AI just proves a bunch of stuff like really quickly because you can just do this indefinitely, rapidly improve, right? But then like what if you're trying to do something where you are like planting a tree, right? Like how do you make it where you could say the AI is objectively better at, let's say, gardening, right? Because maybe I plant my orange tree and I have to wait 20 years for the tree to grow to start blossoming oranges. So like how are you supposed to get that feedback, right? So in a certain sense, like when we do gardening, a lot of that information has kind of been passed down through traditions over time to say like, hey, this is how you go. And then, I don't know, like plant your corn. Oh, it should be knee high by the 4th of July. And you have all these different sayings of how people will do farming over the years. And we had just like oral traditions of all the humans. And it's not clear to me like how the AI model would be able to become even superhuman at something like gardening, just because the feedback loop would be so slow.
Mm.
So I think that you could potentially map, or you could mimic what humans do, and then I think that you could have an AI robot that maybe is able to plant crops and stuff as efficiently as humans because it just mimics what humans do.
Mm-hmm.
But in a certain sense, the way humans have been able to get really good at gardening, it took maybe 10,000 years or something,
Yeah.
of just trial and error and seeing how to grow the crops, right? So the fact that you're dealing with a physical thing, it might take a lifetime to actually get the enough feedback to know what you're doing. So it's not clear to me if we're ever going to have like superhuman farm robots, only robots that are able to match humans. So I was thinking like, man, how does this work? And then, oh yeah, I have a couple ideas of how you'd approach that, but that's just something that I'm thinking like, man, it may be really, really difficult to beat humans at that. I don't know if you have any thoughts.
Well, I have a lot of thoughts there. I mean, by definition, they will get better at humans after a lifetime. It might take a long time, but also, what lifetime are you talking about? An AI model only needs until like the lifetime of that plant to figure out everything that is required to make that plant grow. And it could, split up an 1 acre plot into tons of different rectangles and plot tons of different plants. Look at the interactions between each plant, the adjacent plants next to it, the amount of water that goes into it, the amount of sunlight coverage, the amount of pests that are in it, and just the sheer amount of data that it can get in agriculture is, I think, beyond what people process right now. And yes, I think it will take a couple lifetimes of the plant that you want to optimize in order to figure out how to best grow that plant. But, just spitballing, hypothetical scenario, I think if we're able to get AlphaFold to predict protein sequences, we could theoretically build some kind of a world, maybe not biology model, because that's a little too low level, but maybe like a world agriculture model that can just figure out what's going to happen before it even happens and run tons of simulations and try to maybe validate those hypotheses and then make the model even better. World agriculture model.
Yeah, the world agricultural. I mean, I think that's where we need to go. So I tend to agree. So I think the first one you mentioned, where you have the robots all just trying to grow the plants in different scenarios, I think that's what I was thinking about too. So I actually had a long conversation with Lonnie Chrisman last week. So Lonnie is an awesome guy, super smart, CTO of Analytica. And if you want to learn a lot more about Lonnie, check out our previous podcast episode titled, I think it's the most wonderful engineer in the world, most wonderful engineer.
The best electrical engineer in the US.
That's what it's called, yeah.
He was voted the number 1 electrical engineer. I think he was at Berkeley a long time ago, but I think he's still very sharp and very, very smart and has a lot of amazing insights.
Yeah.
And he does work on the product Analytica. I think the parent company is Lumina.
Yeah, sounds right.
And they build modeling software to model complex scenarios for governments, large factories, and just large organizations that want to simulate, I think, anything. Model complex systems together, like a factory, like maybe like an agricultural plant or a renewable energy solar power grid, and see how those different factors interact with each other.
Yeah, so I talked to Lonnie for maybe 2 hours last week, and I was talking to him about this particular thing, trying to form my thoughts, get what he thinks about this. And he mentioned that there was kind of 2 ways to deal with this. The first one, which is kind of what you talked about, is federated learning. So he used the term federated learning. I actually didn't know what federated learning was, to be honest, at the time. But federated learning is apparently where you have multiple different like robots or things are running simulations at a time, and then you have all of them kind of combine their information together. So an example that you gave with the plants, we have 1,000 different plants. You try to grow each plant under different conditions, maybe more water, more light, less light, more shade, less shade, fertilizer, no fertilizer, different types of fertilizer, etc. Bigger space between each plant, using a cover crop, whatever. Put all these together, and then you just combine all that information together, and then you can maybe get some sort of different world model. So where it would take maybe one human multiple lifetimes, if you had 1,000 robots all working together, you could get something much faster. Now you still have to wait for the plant to grow,
Mm-hmm.
but you get many plants, and it might be the lifetime of the plant. So you probably get lots of information really, really quickly.
Mm-hmm.
And especially if you do this over the entire world,
Mm-hmm.
you could do something. And then, so that's one thing. And then the second thing he mentioned, which I think you kind of touched on as well, was
Simulations.
simulations. Yeah. So with simulations, you could hypothetically turn up the speed on how long it takes to bring something. But then I was thinking about simulations. So, well, simulations are never 100% accurate.
It's like an imitation of the real world. There are always some simplifications we take, some shortcuts. I mean, even the laws of physics, as we understand it right now, is like an approximation of reality. Newton's laws are not real, but they're a good approximation, and I think very useful for engineers who want a simplified model to deal with, building things in the real world.
Yeah, exactly. So Lonnie's intuition was we'd maybe get to about, we could with simulation maybe get to about 90% as good as the real world. But at the end of the day, I think that you can never reach 100% because sometimes you just need to see how things go into the real world. Because, as they say, all models are wrong, but some are useful.
Somewhat useful, yeah.
Yeah.
And I think we can see a good example of that with the new NVIDIA DLSS, which uses ray tracing and a bunch of approximations to figure out, okay, we have a bunch of lights here, but if this was a simulation, how would that light in front of us bounce off of my phase, which is also lit, and it would reflect off of my phase, go onto Mark's glasses over there, and then again bounce off into the camera's lens. So it's a lot of bouncing, and the actual computation for every single ray of light is insanely complicated. So NVIDIA came up with a lot of approximations to figure out this problem of ray tracing. And it has like mixed reviews.
So, sorry, you said DLSS. What is that?
Yeah, I think it's like DLSS.
Did you come up with it recently?
Yeah. Is it deep learning super sampling? It's a form of fancy term to upscale footage and kind of fill in the frames between the actual frames that are generated by the GPU and make it seem like the game is running at a higher frame rate than it actually does. And when everything goes well, you're getting this like 200 frames per second in a game which looks buttery smooth. But if you're taking actions in the game where your character is maybe doing things that challenges the GPU and darting from left to right and changing directions haphazardly to confuse this AI sampling, it would predict a frame based on its world model that uses ray tracing, but it would get it wrong and then have to like go back. So I think this is like a interesting real world example of using simulations to extrapolate what is happening in reality, and it's gotten mixed reviews. NVIDIA is touting the benefits of AI generated frames, but a lot of hardcore gamers hate this because they're like, this is not reality. I'm playing a first person shooter. I need to know exactly what is happening on my frame. I don't want some simulated frame telling me, okay, my enemy's over there when he's actually one pixel to the right. So, yeah.
Man, imagine you were so good at games that it mattered one pixel. It's like, where am I shooting? Like that's insane.
I'm just speculating.
I mean, you might be right. I mean, some of these people are really good at these
I
games.
have watched a lot of YouTube reviews of the new NVIDIA chips that came out, and the demo at CES was incredible. I was sold, but when actually looking at gamers' reviews of the new cards, it seems like it's not all that what it's cracked up to be.
Really?
Yeah,
That's too bad.
no one likes AI generated frames.
Huh.
Yeah,
That's surprising. I would have thought that people would have liked it because they could have, um, but I don't know, but because I don't play a lot of games, so I
me
would
neither.
think that getting an extra frame, because if I go from 60 frames per second, which I can't see all the frames,
Yeah.
to 240 frames per second, I feel like I'd want to have the more frames. But apparently they want more accuracy. It's like, how much of a freak are you to say, oh yeah, I could just go and tell my one pixel. It's like, oh, that, and he runs to the door. I snipe him there.
Okay, so my assumption of the real world impact is that you're going to see a bit of stutter, jank, um, some artifacts when it's predicting some frame, and then it has to overcorrect because the actual frame is a little bit different. The actual next frame after the predicted frame is sufficiently different.
Oh, okay. So it kind of looks stuttery or
Yeah.
something. Oh, okay. That makes sense. So it's not just like, oh, one pixel.
Yeah.
Well, maybe it is, right? Because maybe it's just like stuttering between a couple pixels. It's kind of like a little bit of aliasing, anti-aliasing, whatever that is.
Right.
And I could see it. I could see it.
And user perception is like very tricky too. It doesn't matter if it's like 30 frames, 60 frames, or 120 frames per second. If there's a little bit of jank at 100, 200 frames per second, that is way more noticeable than a consistent 30 or 60 frames per second.
Yes, that makes sense to me.
That's something we learned when I was working on Stadia, the cloud gaming technology.
You worked at Stadia?
Yeah.
Oh, cool.
So specifically, I jumped on the project last minute to try to deliver on the high frame rate for our pro subscribers. I forget the whatever paid tier, and it was really hard. And we tried very, very hard to make sure that there was no jank, there was no stutter, because that was way worse than reducing the resolution and delivering like a lower bit rate, but a consistent frame rate.
Huh. Yeah, I thought a lot of people really like Stadia. It's unfortunate they shut it down.
Yeah.
But I do think cloud gaming is pretty incredible. Like
it seems like it's gotten really mainstream. I think some of the newer TVs just have NVIDIA's or Xbox cloud streaming built in. You can just like buy a new Samsung TV, get a controller, and start gaming.
Yeah, I just bought a new laptop here. So this laptop is the first laptop I've had basically forever that could play games.
Nice.
So that's been pretty fun. But I've been using cloud gaming for my MacBook Air, and it's great. But the problem is you need to be connected to the internet, and that is unfortunate because sometimes you want to play games when you don't have internet. So, for example, if you're on a plane and you want to play games, good luck using cloud gaming.
Maybe if you have Starlink.
I guess, yeah. But I do a lot of trips over to Asia, and there's not really good internet on those planes. Like you're just over the Pacific Ocean, right? Yeah. Anyways, so getting back to kind of the conversation we had between like what are the limits of reasoning, and then going like to the federated learning techniques and the simulation. I was sort of thinking like what would like ASI, like the thing where we have superhuman intelligence, what would that look like, right? Because if let's say loosely, we have AGI, which would be the robot is roughly equal to humans, and then if we have ASI where it's far superior to humans, I think that my question is like, what domains would we be able to get it where we are better than humans at all things, and then like what would the world even look like if it was able to surpass humans at all those things. And like, let's say like a 50 years from now or 100 years from now, where we're able to, surpass all those things in the limit, like what does the world look like? And then also, like what do we do with that, right? So it's like, okay, fine, we have chess playing bots that are able to beat humans at chess. Humans still play chess, it's still fun, right?
Mhm.
Um, do we just make it that in the future that we just allow the robots to do like all of our math and all of our science, and we just let them figure that all out, and then we just do the human related things by, I don't know, writing the stories and singing the songs and doing the art, because that is what the humans are, we like to do, and then we just do all those things. Like, I don't know, I'm just trying to think of what that world looks like. And um yeah.
Or something more sinister where we're trapped in the matrix and we're all hooked up to a computer that is sucking all the training data it can out of our brains and putting us in simulated environments to feed the neural networks to get better. Because one funny uh, kind of ad that I've been seeing lately is for experts in certain domains to do studies or trials where they sit and have you just solve a bunch of problems, do a bunch of work in your domain, and they study you to get training data. But yeah, I don't know. In both scenarios, I think far into the future, computation is just going to keep getting more powerful. We're going to get models that are more capable. Every single domain, I think, is going to reach or surpass human intelligence. And at that point, yeah, I'm hoping we just get to sing, dance, play chess, do whatever we do right now for fun. And there's some kind of a universal basic income or socialist policies that are enacted where people have the freedom to live their lives without worry about sustaining themselves.
So I really hope so.
Yeah.
So to kind of go back to the conversation I had with Lonnie,
Uh-huh.
we were talking about likely outcomes for this future.
Uh-huh.
And one, which actually I think is super likely,
Mm-hmm.
is, right now there's maybe 20 or so companies that are making these foundation models and are making humanoid robots, right?
Mm.
Ish, right? Maybe called 100 max, right? There's not that many companies doing this kind of like deep um, research. Now,
Mm-hmm.
what's totally possible is if you have these companies go and try to make and you make them like super intelligent, way better humans at all the tasks, then in theory, all of these jobs that the people used to do
Mm-hmm.
would now be better done by the robots more cheaply, right? And maybe it can do translation equal to humans, and maybe for like math and science and stuff like that, it'll be better than humans. So then uh, you can make it so that like the humans don't really have any jobs anymore because the robots are just able to do everything, either equal to or better than humans, which I think is what we'll get to the point at. So then now that the robots can do everything, but it's those, let's say 20-ish companies
Mm.
that own all the robots. So it's totally possible that those companies just own all the robots, do all the work, and then
Reap all the benefits.
exactly, and they subjugate all the humans. And then what are you going to do? It's like they got their army of robots
Yeah.
that can go and stop you. It's like you say death to the robots, and they say, well, we're just gonna use our laser beams and just like go kill all the humans because we don't need you anymore. And then you just have
Or more, maybe not kill the humans, but put all the humans behind a paywall where you can't do anything because the world is run by robots and you need access to technology to do even basic things. And you need to pay these corporations in order to live life.
right. So when I was talking to Lonnie, he said, yeah, I think that's probably one of the more likely scenarios. And I was like, man, I hate to say it, but that seems actually kind of realistic. Because you think about how much our life, even now, is kind of controlled by corporations. It's really, really hard to live your life without going through a big corporation, right? Um, I mean, think about in California, there's only one electric company, right? You have to go through PG&E for pretty much everything, right? If you want a phone, it's going to be Android or iOS. I mean, sure, you could use a Pine phone and run Linux or something like that, or you could use a really outdated Windows phone. But in a certain sense, there's only kind of two companies that control
Hmm.
the entire smartphone market, right?
Hmm.
If you want to take a plane, you're going to go on just like one of three airlines or something, right? So like the entire world is filled with oligopolies.
Hmm.
Um, and I think that a lot of these companies, if they could replace all their workers with robots and say, hey, you need to go through us for everything, and then you want to stop them, it's like, what are you going to do? It's like they've got all the robots. They have all the money that you don't have a job. You just
Hmm.
beholden to the company for everything, and they just kind of subjugate the humans.
Hmm.
Uh, I am a little bit worried about that future because I feel like that actually feels somewhat likely. Um, and maybe we could say, oh, well, we have some open source models.
That's what I was going to say.
Yeah.
I think maybe a year before this, maybe 2 years ago, when OpenAI first came out with ChatGPT, and they were by far the leaders in the space. And maybe we had Google that was kind of trying to catch up and releasing similarly capable models. We were like, okay, AI is in the hands of the corporations. Now we have a significant amount of open source models that are uh, like on par and in some specific domains beating these closed source models from these mega corporations. So I don't know. And I think if you're trying to compare it to infrastructure companies like telecom and stuff, I don't, or let's say Facebook and Amazon, these companies don't function, or like LLMs don't function the same as the internet age companies. You don't need network effects like Amazon needs to build the largest marketplace. You just release your own LLM with research that you find online and maybe run it on low power hardware, and then boom, you have your own model. Um, Maybe if we're thinking about robotics, you might need more capital, a lot of actual money, factories to manufacture and produce these humanoid or whatever shaped robots. That maybe I can see being in the hands of a few corporations, maybe China, countries that control access to these technologies. But I think at the very bare minimum, LMs will always be widely available, maybe even free, probably some level of open source. Um, but again, this is very early. Who knows if the final form of the most commonplace AI that people use will be ChatGPT, or if it'll be like C3PO or some kind of a humanoid or other anthropomorphic robot that we talk to and interact with. So I guess that it depends on what form of AI we're dealing with um, 10, 20 years down the line.
Yeah, I guess you're right.
I could see like there being open source stuff, an open source Jarvis, like this omnipresent AI that is um, installed on all of your devices, your watch, your phone, your laptop, your TV, and it just follows you around and talks to you and is fully aware of everything that's going on and is helpful throughout your day. That I can see there being open source alternatives.
Yeah, so I really hope that the open source will work well because I think that you, me, we would know how to take advantage of the open source. And actually, I think you, listener, will also know how to take advantage of the open source because you seem to be a person who likes science and technology, and you're probably into the open source, right?
Yeah.
But what I'm kind of worried about is the person who is not an AI enthusiast, right? The type of person who's listening to the show is an AI enthusiast and is on the bleeding edge of what is happening, right? But I'm talking about, your average Joe Schmo who doesn't know uh, an LLM from a cheeseburger, right? you know, uh, this is like it means nothing to them, and uh, I'm worried that they will be the ones who are potentially subjugated by all of these robots, and I hope not, right? Like I hope that um, they're the ownership of these superhuman robots will be shared and spread throughout society, and it won't be in the hands of the companies. And I hope we're a lot more like the United States, where things are. I mean, there's still a lot of income inequality in the United States, but I'd say the standard of living that a lot of people have in the United States is pretty decent overall, right? But I hope it doesn't become like North Korea, where all of the uh, capital and resources go to just like a few people at the top, and then everybody else just ends up working for the robots. Uh, and maybe we'll see both. I'm not sure, but it's something that like I worry about, just having a couple companies like own all the robots and do all the things and own all the jobs, and then it, like hopefully like the humans will be able to buy those robots, and then like it's like, hey, this is my robot that takes advantage of the farm. But I'm not sure, so we'll see. But this is shower thoughts at night.
I mean, I think this is more than shower thoughts for a lot of people. I think this is probably why a lot of the leadership at OpenAI decided to wage a coup and oust Sam Altman. This is probably why Elon is trying to buy OpenAI, because he feels that corporations may not have the best interest of the world at large. This is also probably why Ilya Sutskever, who was the head of the chief scientist, I think, at OpenAI, he left to start his own company, Safe Superintelligence, because this is a legitimate concern because of how fast this technology is moving. There's like so much more we can talk about. There's the Paris AI Summit, where a lot of countries tried to convene and tried to agree on how we're gonna manage the development and progress in this field as we go forward, because this is the most impactful technology that we've ever seen. So we need some coordination on a global scale. And this is more than just shower thoughts. This is becoming a very practical challenge, especially as countries are starting to have this sort of like a Cold War with America and China at odds, because the thought is, like you mentioned, the first one to reach AGI, ASI, a high level of intelligence, is going to be the next superpower. And there's some theories floating out there that specifically by this guy who runs SemiAnalysis, which is a research group to study the semiconductor industry, and he thinks that we might have AGI already. It's just that we may not be able to deploy it at scale and make it widely available to every single human out there. But there's probably some company out there who can pour $1 billion of inference time compute and solve really challenging technical problems today, right?
Yeah, I mean that seems probably true, and I mean I feel like AGI is kind of hard to define, to say if we're there, if we're not, because I don't, what does it even mean, right? I mean, I say that AGI is roughly human level intelligence, but it's like, sure, maybe we reached it. Hard to, I don't know.
It's kind of the thing, like it when you see it, and we've tried to distill AGI into some test, but every time we make a test, people beat it. It's like a funny phenomenon. Like as soon as you make any kind of benchmark, there's going to be very smart people out there who are going to game the system to try to beat that benchmark, and that's happened every single time that we've established a test. Even with ArcAGI, we Francois Cholet came out with a test to measure intelligence, and boom, OpenAI beat it. And there were a couple other amateur hobbyists who also reached a very high level of accuracy. I'm assuming some of them did brute force computation. Others tried agentic techniques like OpenAI. But yeah, this concept of AGI is constantly evolving, constantly shifting. We're trying to articulate what that means, but it's just it when you see it.
Yeah, I think that makes a lot of sense. It reminds me because I think I was just Googling that term. I know it when I see it. And apparently there's a whole Wikipedia page on I know it when I see it. So it came from, well, it was really famously used in this court case called Jacobellis versus Ohio, where it was actually it was a Supreme Court case where they were trying to determine if something was quote unquote like obscene. So
Pornography.
yeah, if it was pornography, right? And the guy said, well, it's really hard to define porn, but I want to see it. And I think AGI is similar. On that note, yeah. So, anyways, we've been talking for a while now. So, yeah, that was fun. I think we could keep going for a few more hours, but
yeah, hopefully we don't reach AGI before the next episode. But we'll see you in the next one.
Yes, and I'll know you when I see you. So, catch you in the next one. Bye.
That's funny.